Hi everyone, welcome back to the Big O series. In the previous videos, we introduced the basics of Big O notation and some of its key properties. Today, we're going to talk about one of the most ideal types of complexity, O of 1, also called constant time complexity. What this means is that no matter how large the input is, the runtime of the algorithm does not change with the size of the data. In other words, whether you have 10 items or 1 million items, the execution time is about the same. Let's look at a simple example, getting the length of a string. In Python, calling len of s directly returns the stored length of the string object. It doesn't need to loop through every character. Whether the string has 5 characters or 5 million characters, the time to get the length is fixed. That makes this a classic O1 operation. Now let's look at another common case, accessing an array element by its index. This also has O1 complexity. Why is that? Because an array is stored in a continuous block of memory, like a row of rooms numbered in order, each holding one element. When we access an element by index, the computer uses a simple formula: the starting address plus the index multiplied by the size of each element. That calculation gives the exact address, and the computer jumps straight there. For example, accessing AR bracket 3 means starting from index 0 and moving 3 positions forward. It's a single step to locate and retrieve the value. Whether you access index 3 or index 1 million, the computer still does just one address calculation, so the performance is the same. For the third example, let's talk about hash tables. Insert, lookup, and delete operations in a hash table are usually O1 as well. Here's how it works. The hash table uses a hash function to turn a key, like the string apple, into an integer. That integer corresponds to a specific location in the table, so we can go directly to that spot and find the data. In the ideal case, both the hash function calculation and the jump to the memory location take constant time, which makes these operations O1. Of course, hash tables can have collisions, but that's a topic we'll cover in a future video. To wrap up, the key feature of O of 1 complexity is that the execution time is fixed and does not grow with the size of the input. Common examples include getting the length of a string, accessing an array element by index, and performing insert, lookup, or delete operations in a hash table. In real-world engineering, O of 1 operations are often the kind of performance we strive for first.